The seafloor between Australia and Antarctica does not announce itself. It does not broadcast. It moves in silence, under pressure, at a pace measured in millimeters per year. On the afternoon of the 27th of May, 2026, that slow motion fractured, twice, 11 minutes apart, at the same coordinates, at the same depth, with the same magnitude. The United States Geological Survey Catalog logged the first event at 1451 Coordinated Universal Time. Magnitude 6.0, latitude 50.46 degrees south, longitude 139.44 degrees east, depth 10 kilometers, no tsunami flag, no population within 1,000 kilometers, the kind of entry that passes through automated systems without triggering human attention. 10 minutes and 6 seconds later, the catalogue refreshed. A second magnitude 6.0, identical coordinates to the 100th of a degree, identical depth, identical magnitude, same plate boundary, same fault system, two distinct ruptures, one shared location on a global earthquake map. The two events do not render as separate points. The cartographic resolution of the interface is coarser than the spatial separation between the ruptures. They overlap. They sit on top of each other. To anyone viewing the feed from a distance, it looks like a single earthquake that repeated. That is not what happened. Two independent seismic sources released energy in the same patch of oceanic crust within a window short enough to feel like a glitch. The first reaction inside seismological networks was exactly what it would be anywhere else. Verification, cross-reference, algorithmic check for duplication. The waveforms arrived at recording stations on Tasmania, at Macquarie Island. Along the Antarctic coast, the travel time fingerprints were distinct, the phase arrivals were distinct, the onset times were distinct. The data was clean, the events were real. This kind of pairing is rare. Not because earthquakes do not happen often. They do. The global catalogue registers tens of thousands of events every year. The rarity comes from the pattern. Most seismic sequences follow established decay curves. Omori's law describes how aftershock frequency drops over time, falling off roughly with the inverse of the elapsed interval. Barth's law describes the magnitude relationship between a main shock and its largest aftershock. The largest aftershock is typically 1 magnitude unit smaller. A 6 is followed by a 5. A 7 is followed by a 6. The pattern is consistent enough to serve as a baseline. The doublet on the southeast Indian ridge did not follow it. The second event matched the first. Neither was clearly the foreshock. Neither was clearly the main shock. They were equal, comparable, released within a narrow temporal window at a single geographic node. That is the textbook definition of a doublet in seismology. Two earthquakes of similar size. Short time separation. Shared location. It exists in the global record. It appears across tectonic settings. It remains statistically uncommon. The location itself dictates how the event behaves. The coordinates place the rupture in the Southern Ocean, between the southwestern coast of Tasmania and the Antarctic continental margin. The nearest land is 1,000 kilometers away. The nearest scientific outpost sits several hundred kilometers to the east. There are no cities on the seafloor, no shipping lanes close enough to feel the shaking, no instruments mounted on the ocean bottom near the epicenter. Everything we know about the rupture comes from seismic waves traveling through the mantle and crust to land-based stations hundreds and thousands of kilometers away. Distance changes precision. The closer the sensors, the sharper the location solution. The further the sensors, the more the reconstruction relies on assumptions about wave velocity, crustal density, and mantle structure. The reported depth of 10 kilometers reflects that reality. It is partly measured, partly assigned. When waveform inversion cannot tightly constrain depth, catalogues default to 10 kilometers as a structural placeholder. The ruptures occurred in the upper oceanic crust. They likely sit somewhere between 5 and 20 kilometers down. The exact number carries uncertainty. The magnitude estimates carry uncertainty. The precision reads 0.1. The actual error margin matches that precision. The two events could differ by an amount the catalogue cannot resolve. That is not a failure. It is honest reporting. The Southern Ocean is one of the least instrumented seismic regions on Earth. Dense networks exist in Japan, in California, in Chile, in Iceland. Those networks do not extend into the deep southern basins. The stations that recorded this event sit on the southern Australian margin, on Tasmania, on scattered sub-Antarctic islands, on the Antarctic continent itself. They are the eyes available. They are far from the source. They captured the signal. They reconstructed the origin. They confirmed 2 ruptures. They could not capture the millisecond propagation history. They could not resolve the exact fracture geometry. They provided enough to confirm the event. Not enough to map every detail. The naming of the location carries its own history. The United States Geological Survey labels this segment the Western Indian Antarctic Ridge. The designation reflects older catalogue conventions. The geophysical community calls it the Southeast Indian Ridge. The feature extends eastward from the Rodriguez Triple Junction in the central Indian Ocean. It runs through the gap between Australia and Antarctica. It terminates near the Macquarie Triple Junction southeast of New Zealand. The doublet occurred near the eastern end of the ridge, before the structure transitions into the more complex Macquarie Ridge system. Different names, same boundary, same physics. The boundary itself is the interface between 2 major tectonic plates. The Australian plate sits to the north. It carries the continent of Australia. It carries a wide section of the Indian Ocean. It carries portions of the Coral Sea and the Western Pacific. The Antarctic plate sits to the south. It carries the continental mass of Antarctica. It carries a broad ring of surrounding seafloor. The 2 plates are moving apart, slowly, steadily, for tens of millions of years. The ridge marks where that separation happens. The earthquakes mark where the stress releases. To understand the rupture, you have to understand what a mid-ocean ridge actually is. Drain the oceans for a moment. Look at the bare seafloor. The most dominant feature is a continuous chain of underwater mountains. It runs through every ocean basin. It circles the planet. It measures roughly 65,000 kilometers in total length. It rises from the abyssal plains to peaks several kilometers high. A deep central valley runs down the middle. The system is called the Global Mid-Ocean Ridge. It is the longest mountain range on Earth. It dwarfs the Andes, it dwarfs the Himalayas, it remains hidden beneath water. That is why it rarely enters public awareness. The ridge is not a mountain range in the traditional sense. It is a creation zone. New oceanic crust forms here. The upper mantle beneath the ridge axis is hot. Rock there is partially molten. The melt is less dense than the surrounding solid material. It rises, it reaches the seafloor, it spills outward. It cools rapidly in contact with near-freezing seawater. It solidifies. It attaches to the edges of the plates on either side. The plates move apart. The new crust gets pushed outward. Fresh melt rises behind it. The cycle repeats. The result is a clear age gradient. The crust closest to the ridge is young, sometimes only thousands of years old. The crust at the far edges of ocean basins is old, hundreds of millions of years. The process is called seafloor spreading. Its discovery in the 1960s transformed Earth science. It provided the mechanism that continental drift lacked. It explained why continents move. It explained why magnetic stripes align parallel to ridge axes. It explained why the seafloor ages systematically away from spreading centers. The Southeast Indian Ridge is a mature segment of that global system. It has been active for tens of millions of years. The plates on either side diverge at an intermediate rate, approximately 65 to 75 millimeters per year. 6 to 8 centimeters, roughly 3 inches, slow on a human scale, enormous on a geological scale. Sustained over 30 million years, that rate generates 2,100 kilometers of new oceanic crust. That is the width of the basin between Australia and Antarctica. The motion is continuous. The crust is forming right now. The system is running. Ridges are not straight lines. They are not continuous. They are segmented, offset, connected by features called transform faults. A transform fault is a horizontal slip structure. It links two ridge segments that are misaligned. One segment runs roughly east-west. A transform fault cuts across it, roughly north-south. The next ridge segment continues east-west. Shifted south. The pattern repeats. The ridge segments are where new crust forms. The transform faults are where the plates slide past each other. Accommodating the offset. The transform zones are where most earthquakes occur. The ridge axis itself produces relatively few large quakes. Spreading there is accommodated by magma intrusion, by ductile flow, by gradual extension. The transform faults are brittle. They lock. They accumulate strain. They release it suddenly. That is the mechanism behind the doublet. The seafloor was not splitting open vertically. Two blocks of crust slid horizontally past each other. One block moved. 11 minutes later, the adjacent patch moved. The doublet recorded that sequence. The mechanisms explains the absence of a tsunami. Earthquakes do not all move the ground the same way. The direction of motion determines whether water above it will displace vertically. Subduction zone earthquakes involve one plate forced beneath another. The overriding plate snaps upward during rupture. The seafloor lifts by meters across hundreds of kilometers. The water column moves with it. A long wavelength wave forms. It travels at hundreds of kilometers per hour. It piles up in shallow water. That is a tsunami. Strike-slip earthquakes involve horizontal motion. Crust on one side moves one direction. Crust on the other side moves the opposite direction. The boundary slips laterally. The seafloor shifts sideways. The water column above it does not lift. It flows around the displacement. No vertical displacement means no tsunami generation. The Pacific Tsunami Warning Center, the National Tsunami Warning Center, regional monitoring networks all use the same physical criteria: magnitude, depth, focal mechanism, coastal proximity. They evaluate whether vertical seafloor motion occurred. Strike-slip events on transform faults do not produce that motion. No warning is issued. The system is mechanical. It responds to physics. It does not suppress data. It evaluates risk based on displacement geometry. The doublet fits that geometry. It occurred on a transform fault, offsetting the ridge. The rupture involved strike-slip motion. The seafloor moved horizontally. The water column remained stable. The physics determined the response. The response matched the physics. That is why the event registered as significant in catalogues but carried no immediate threat to human populations or coastal infrastructure. It was remote, it was horizontal, it released energy without vertical water displacement, it was safe, it was also unusual. Two equal ruptures, 11 minutes apart, same location, same fault system. That coincidence demands explanation. The mechanism explains why it was harmless. It does not explain why it happened twice. That requires looking at stress accumulation, at fault segmentation, at the physics of triggered rupture, at the structure of the local crust. The doublet is not a glitch. It is a signal. It is a snapshot of a plate boundary doing its work. It is a rare but explainable event. It fits within established seismological frameworks. It does not require exotic explanations. It requires careful observation. When the catalogue entries appeared, a different narrative moved faster than the scientific verification. Within hours, a framing attached itself to the coordinates. The doublet was presented as evidence of planetary growth. The claim was simple. The Earth is expanding, the radius is increasing. The continents once fit together on a smaller sphere. The oceans opened as the surface stretched. The ridge earthquakes mark where that stretching continues. The science taught in textbooks is wrong. The planet is growing toward the size of Jupiter. The framing spread quickly. It used real observations. It cited real features. It felt intuitive. It bypassed measurement. The expanding Earth hypothesis is not new. It has a documented history. It emerged from legitimate scientific questions in the early 20th century. It gained traction when continental drift was still controversial. It offered a geometric solution to a problem that lacked a clear mechanism. The intuition behind it is easy to understand. Look at a globe. Shrink it to roughly 60% of its current diameter. The continental shelves align more tightly. Africa and South America close without gaps. Australia, Antarctica, India, Madagascar assemble into a coherent landmass. The visual fit is striking. It feels like a puzzle piece snapping into place. Add the observation that mid-ocean ridges produce new crust. Add the observation that ocean basins widen over time. Combine the visual geometry with the spreading process. The conclusion feels parsimonious. The Earth is growing, the crust is stretching. The continents are drifting apart because the surface area increases. The hypothesis was developed seriously. It was not invented for social media. It was proposed by engineers and geologists working with the best data available. In 1933, Otto Christoph Hilgenberg published a model called the growing Earth. He constructed papier-mâché globes. He fitted modern coastlines together on a reduced sphere. He argued that the planet had expanded since the Mesozoic. He proposed that mass and volume increased over time. He suggested an ether absorption mechanism to explain the growth. The ether concept was already obsolete in mainstream physics. The Michelson-Morley experiment had eliminated the luminiferous ether decades earlier. Einstein's relativity provided a framework that made it unnecessary. Hilgenberg's model was visually compelling, mechanistically weak. It circulated outside the geological mainstream. It was not widely adopted. The next major figure was Samuel Warren Carey, an Australian geologist. A founding professor at the University of Tasmania, he advocated for continental drift when it was still debated globally. In 1956, he hosted a symposium on continental drift. The proceedings were published in 1958. Carey developed an expanding Earth model independently of Hilgenberg. He only learned of the earlier globes after his own ideas formed. Carey worked with emerging seafloor topography data, with earthquake distribution patterns, with the newly documented global ridge system. He observed that crust was created at ridges. He questioned whether an equivalent rate of crust destruction existed. Subduction zones were known. Deep trenches around the Pacific Rim were mapped, but direct measurements of consumption rates were not yet available. Carey concluded that spreading outpaced subduction. He argued that total surface area must be increasing. The continents drifted because they were carried on an expanding sphere. In 1976, he published The Expanding Earth. The book laid out detailed reconstructions. It argued for planetary growth. It kept the hypothesis alive as a minority position through the 1970s and 80s. Carey's objection was reasonable for its time. The data required to test it did not exist yet. Science progresses by identifying gaps, by raising inconsistencies, by forcing the community to measure. Carey did his job. The measurements arrived. The hypothesis did not survive them. The viral framing circulating today strips the historical context. It removes the scientific caveats. It presents the visual fit and the spreading observation as proof. It ignores 70 years of geophysical measurement. It operates on a question that was open in the 1950s, closed in the 1980s, refined continuously since. The framing persists because it uses real observations. The ridges are spreading. The continents do fit visually on a smaller sphere. The standard Pangaea reconstruction includes a vast single ocean called Panthalassa. Critics have asked why that ocean was so large, why the geometry appears asymmetric. The expanding model removes that asymmetry by eliminating the excess ocean space. The visual elegance is real. The intuitive pull is strong. The problem is not the evidence it cites. The problem is the evidence it excludes. Geodesy changed the debate. Satellite laser ranging emerged as a precision tool. Lasers measured distances between ground stations and orbital reflectors. The data tracks crustal motion. It tracks planetary dimensions. Very long baseline interferometry uses arrays of radio telescopes. It measures the positions of distant quasars. It calculates the relative positions of the telescopes themselves. It detects crustal shifts. The Global Positioning System provides continuous displacement records. Stations' worldwide report position changes down to millimeters. Gravity mapping satellites like GRACE monitor mass distribution shifts. These systems do not rely on geological inference. They measure physical geometry. They track radius. They track surface area. They track volume. The results are consistent. Earth's average radius is not increasing at the scale required by the expanding hypothesis. Measurements constrain the rate of change to approximately 0.1 millimeters per year. The uncertainty range encompasses 0. Within current precision, the planet is neither growing nor shrinking. It is stable. The expanding model requires a radius increase of roughly 2,500 kilometers over 250 million years. That averages to about 10 millimeters per year, 100 times larger than the measured uncertainty. If the Earth were expanding at that rate, geodetic networks would detect it immediately. They do not. The measurement stands. It is independent of geological theory. It is a direct observation of planetary dimensions. It falsifies the expansion claim as a quantitative proposition. The visual continental fit also shifts under scrutiny. Alfred Wegener noticed the continental alignment in 1912. He proposed continental drift on a fixed-size Earth. He did not argue for radius change. Modern plate reconstructions test the fit on a stable sphere. The alignment is strong. Africa and South America match along continental shelves. Eastern Gondwana assembles cleanly. The geometric tightness is excellent on a fixed-radius globe. The Panthalassa Ocean existed because the supercontinent occupied only a fraction of the surface. The Pacific Basin preserves its geological trace. The visual fit on a smaller sphere is a geometric artifact. It arises from closure constraints. It does not indicate a smaller past planet. The reconstruction works without expansion. It requires only plate motion on a stable surface. The expanding hypothesis also faces mechanical constraints. Crust creation at ridges is documented. Crust destruction at subduction zones is equally documented. The Pacific Plate subducts beneath the Aleutian Arc at roughly 6 centimeters per year. Beneath Japan, at roughly 8 centimeters per year. Beneath Tonga Kermadec at 8 to 9 centimeters per year. The Nazca Plate subducts beneath South America at 6 to 10 centimeters per year. Global subduction rates have been measured using paleomagnetic stripes, using GPS tracking, using plate motion models. When summed, subduction consumption matches ridge creation within measurement uncertainty. The surface area budget balances. Crust is created, crust is consumed. The net change is 0. Carey's original objection relied on an underestimate of subduction speed. The estimate was unavoidable in 1956. The data did not exist. The measurements now exist. They close the budget. They remove the mechanical justification for expansion. The hypothesis also conflicts with rotational dynamics. Earth's moment of inertia depends on mass distribution and radius. If the planet were growing, the moment of inertia would increase. Angular momentum conservation would require the rotation rate to slow. Earth's rotation is slowing, approximately 1.5 milliseconds per century. The rate is well documented. It matches the energy transfer caused by lunar tidal friction. The Moon raises ocean tides. Friction dissipates rotational energy. Angular momentum transfers to the Moon. The Moon recedes. Earth slows. The observed rate aligns precisely with tidal calculations. If Earth were expanding at the rate proposed, the additional moment of inertia would slow rotation by approximately 30 milliseconds per century, 20 times faster than observed. The measured slowdown leaves no room for expansion. The physics is clear. The rotation record is consistent with tidal friction alone. It does not support radius growth. The energy and mass budget presents another constraint. Expanding Earth requires mass addition. The ether mechanism proposed historically is not a physical phenomenon. Modern versions rarely specify a mechanism. Any viable mechanism must supply mass at the required rate. Growing from 60% of modern diameter to current diameter over 250 million years requires adding roughly 1 sextillion kilograms of material. That averages to 300 million tons per second, continuous, uninterrupted for geological time. The only known source of external mass is meteoritic accretion. The measured rate is approximately 40,000 tons per year globally. That is 15 orders of magnitude too small. No other mass source exists. No energy flux converts to matter at the required scale. The shortfall is not marginal, it is absolute. The hypothesis fails on conservation laws. It requires input that does not exist. It demands output that violates known physics. The paleomagnetic record provides further constraint. When magma cools, iron-bearing minerals align with the prevailing magnetic field. The orientation locks in. Ancient rocks preserve field direction, they preserve pole position, they preserve paleolatitude. Measurements across continents and through time reconstruct past geometry. If Earth had been substantially smaller, paleomagnetic poles would show systematic distortion. Distances between continents would mismatch. Field geometry would reflect a reduced radius. The record does not show that. The paleomagnetic data is consistent with a stable Earth radius over hundreds of millions of years. Within measurement uncertainty, no expansion is required. The magnetic archive supports fixed surface plate motion. It does not support growth. 6 independent lines of evidence converge. Geodetic radius measurements show no expansion. Subduction rate measurements balance the crustal budget. Paleomagnetism shows stable past geometry. The energy budget shows no viable mass source. Rotational dynamics show no additional slowdown beyond tides. Continental fit works on a fixed sphere. Each line alone falsifies the expanding hypothesis. Together they leave no room for it. The hypothesis was a reasonable speculation when data was limited. It became obsolete when data arrived. The viral framing today circulates the old intuition without the new measurements. It feels true because it uses real observations. It is wrong because it ignores the system that balances those observations. The doublet on the southeast Indian ridge is real. The spreading is real. The visual fit on a smaller globe is real. The conclusion that the planet is expanding is not. The framing mistakes a single process for a global imbalance. It treats crust creation as proof of surface growth. It ignores crust destruction. It ignores geodesy. It ignores rotation. It ignores mass conservation. It ignores magnetic records. It isolates a mechanism and scales it beyond its constraints. That is how intuitive models fail. They capture part of the system. They treat the part as the whole. The Earth does not expand. It recycles. It creates crust at ridges. It destroys crust at trenches. It moves plates on a stable surface. It maintains a balanced budget. It rotates at a predictable rate. It preserves magnetic records consistent with fixed geometry. The system works. The data confirms it. The viral framing does not. The tension between intuitive models and measured reality defines how Earth science advances. It is not a conflict between lay understanding and expert dismissal. It is a conflict between visual geometry and physical constraint. The expanding Earth hypothesis survives in public conversation because it offers a clean narrative. One process, one direction, one explanation for continental distribution. Plate tectonics is messier. It involves spreading ridges, subduction zones, transform faults, slab pull, ridge push, continental collision, rifting, compression, extension. It requires tracking multiple interacting forces across different timescales. It demands acceptance of simultaneous creation and destruction. It asks people to hold 2 opposing motions in the same system. Intuition favors simplicity. Measurement favors complexity. The tension between them is where scientific literacy forms. Geodetic measurement provides the baseline. Satellite systems do not interpret geology. They record position, they record distance, they record gravity. They operate on independent principles. Satellite laser ranging uses optical pulses. Very long baseline interferometry uses radio waves. GPS uses microwave timing. GRACE uses microwave ranging between twin satellites. Each system has different error sources, different atmospheric sensitivities, different orbital dynamics. When they converge on the same result, the result is robust. The convergence on Earth radius stability is not theoretical, it is empirical. The uncertainty range is explicit. The measurement technique is transparent. The data is open. The conclusion does not require belief. It requires reading the numbers. The numbers show no expansion. The numbers show stability within millimeter precision. The tension arises when visual models ignore numerical constraints. Geometry is compelling. Measurement is restrictive. Science follows measurement. Paleomagnetism adds temporal depth. Rocks do not drift independently. They record field orientation at the moment of cooling. Oceanic crust records magnetic reversals. The stripes form symmetric patterns away from ridge axes. Continental rocks record pole positions. The data reconstructs past latitudes. It reconstructs continental positions. It reconstructs plate rotations. The record is messy. It contains noise. It contains local anomalies. It requires statistical filtering. The overall pattern is clear. Paleomagnetic poles align with a stable Earth radius. The fit improves when continental drift is applied on a fixed sphere. The fit degrades when radius change is introduced. The tension here is between reconstruction preference and data fidelity. Smaller sphere models look elegant. They require bending continental outlines. They ignore rotational history. They mismatch pole positions. Fixed sphere models require tracking complex rotations. They align with magnetic data. They preserve paleolatitude consistency. They require more steps. They yield better fits. Science chooses the path that matches observation, not the path that looks cleaner. Subduction measurement closes the spatial budget. Ridges create crust. Trenches destroy it. The balance is not theoretical, it is tracked. GPS monitors plate convergence. Paleomagnetic stripes map seafloor age. Seismic tomography images descending slabs. The data converges on a balanced system. The tension arises when creation is visible and destruction is hidden. Ridges are linear, they are mapped, they are celebrated in textbooks. Subduction zones are deep, they are submerged, they are harder to visualize. The Pacific Ring of Fire marks where crust disappears. The trenches are narrow. The slabs plunge. The process is continuous. The global budget matches. When measurements first became available, the balance was uncertain. The uncertainty fueled expanding Earth arguments. The uncertainty resolved as data improved. The tension now exists only in spaces where data is absent or ignored. The system does not require belief in expansion. It requires acknowledgement of consumption. The consumption is real, it is measured, it matches creation. Rotational dynamics impose physical limits. Angular momentum conservation is not a geological theory. It is a fundamental law. It applies to spinning bodies. It applies to planets. It applies to Earth. If radius increases, moment of inertia increases. Rotation slows. The slowdown is measurable. Earth's day lengthens over centuries. Ancient eclipse records track the change. Modern atomic clocks track the change. Lunar laser ranging tracks the moon's recession. The data aligns with tidal friction models. The match is precise. The tension arises when expansion models ignore rotational consequences. Growth requires slowing. The observed slowing matches tides alone. No additional slowdown exists. The rotation record does not support expansion. It contradicts it. The law of conservation does not bend to visual preference. It constrains it. The tension resolves when measurement replaces assumption. Energy and mass conservation impose absolute limits. Matter cannot appear without source. Energy cannot convert to mass at geological scales without measurable input. The expanding model requires continuous mass addition. The source does not exist. Meteoritic flux is documented. It is small. It is insufficient. The tension arises when models bypass conservation laws. Physics does not allow it. The energy budget is not negotiable. The mass budget is not flexible. The hypothesis fails here not because of geological disagreement. It fails because it violates fundamental constraints. The tension between visual elegance and physical impossibility is not resolvable. The physics wins. It always does. Scientific consensus forms when independent lines of evidence converge. It is not a vote. It is a measurement alignment. Geodesy shows stability. Paleomagnetism shows stability. Subduction balances creation. Rotation matches tides. Mass conservation forbids expansion. Continental fit works on fixed radius. The consensus is not a social agreement. It is a data convergence. The tension persists outside consensus because intuition favors simplicity, because visual models bypass measurement, because narratives spread faster than datasets. The remedy is not dismissal, it is demonstration. It is walking through the measurements. It is showing how each constraint operates. It is acknowledging the intuition that drives the hypothesis. It is replacing it with the data that falsifies it. The doublet on the southeast Indian ridge does not break this framework. It fits within it. The spreading is real. The transform rupture is real. The stress release is real. The event does not indicate expansion. It indicates recycling. It indicates balanced motion. It indicates a system doing what it is designed to do. The scientific tension resolves when observation is separated from interpretation, when measurement is separated from projection, when intuition is tested against constraint. The expanding Earth hypothesis fails those tests. It fails consistently. It fails across disciplines. It fails on fundamentals. The tension does not disappear from public conversation. It remains because visual models are sticky, because simple narratives travel fast, because measurement requires patience. Science does not require patience to exist. It requires patience to understand. The data is clear, the system is balanced, the planet is not growing, it is moving, it is recycling, it is stable. The tension resolves when the full set of measurements is placed beside the partial set. The full set wins. It always has. It always will. The consequences of seismic events on remote plate boundaries differ sharply from those on populated margins. The difference is not in the physics. It is in the exposure. The doublet on the southeast Indian ridge released energy equivalent to a moderate continental earthquake. It occurred under cold ocean, under deep water, under no infrastructure. No coastal populations faced shaking. No harbours faced displacement. No cities faced liquefaction. The physical hazard was confined to the seafloor. The human consequence was confined to information, to perception, to communication. Tsunami warning systems operate on focal mechanism evaluation. They do not issue alerts based on magnitude alone. They assess displacement geometry. Strike slip ruptures move horizontally. They do not lift the water column. They do not generate long wavelength surface waves. The Pacific Tsunami Warning Center, the National Tsunami Warning Center, regional networks all follow the same protocol. Magnitude is noted. Depth is noted. Location is noted. Focal mechanism is evaluated. If vertical displacement is absent, no warning is issued. The system is mechanical. It responds to physics. It does not suppress data. It evaluates risk. The doublet produced no vertical motion. No warning was issued. The absence of a warning was not a failure. It was a correct application of protocol. The public interprets warning absence differently. When large earthquakes occur, the expectation is alert. When alerts do not appear, suspicion rises. The expanding Earth narrative feeds that suspicion. It frames the absence of warning as concealment. It frames the remote location as intentional. It frames the strike-slip mechanism as irrelevant. The consequence is erosion of trust. The consequence is confusion. The consequence is misallocation of attention. Real risks are overshadowed by speculative narratives. Preparedness is diluted by false urgency. The human cost is not measured in casualties. It is measured in misdirected concern, in fractured communication, in the quiet degradation of scientific literacy. Risk perception depends on visibility. Subduction zones produce devastating tsunamis. Japan, 2011. Indonesia, 2004. Chile, 2010. Those events are visible. They are documented. They are felt. The imagery is permanent. The memory is sharp. Transform faults on mid-ocean ridges do not produce that imagery. They produce catalogue entries. They produce academic papers. They produce remote signals. The absence of imagery shapes perception. The absence of casualty shapes attention. The doublet registers as statistically unusual. It does not register as socially urgent. The consequence is a gap between scientific significance and public awareness. The gap is real. It is structural. It reflects how hazard is communicated. how risk is weighted, how attention is distributed, communication systems struggle with remote events. Emergency protocols prioritize exposure, they prioritize population, they prioritize infrastructure. Remote seismicity falls outside those priorities. The consequence is minimal media coverage. The consequence is reduced public education. The consequence is vulnerability to misinformation. When an unusual event occurs in an unobserved region, the vacuum fills quickly. Speculation spreads faster than verification. Visual models outpace measurement narratives. The expanding Earth framing thrives in that vacuum. It offers a complete story. It offers a clear enemy. It offers a simple explanation. It does not require data. It requires intuition. The consequence is narrative capture. The scientific story loses ground to the viral story. Not because the scientific story is weak, because the viral story is shaped for speed. Bisrotch-Grosschot implications remain limited for ridge transform events. No pipelines cross the Southeast Indian Ridge. No undersea cables run directly through the Doublet coordinates. No research stations sit above the fault. The physical consequence is zero. The operational consequence is minimal. Seismic networks record the event, catalogues update. Researchers analyze. The system functions. The public remains unaware. The consequence is isolation. The event exists in scientific records. It does not exist in public memory. The isolation protects communities. It also isolates knowledge. The consequence is a disconnect between what is measured and what is known, between what is documented and what is discussed. Human exposure to remote seismicity is indirect. It arrives through media, through algorithms, through social networks. The exposure is cognitive, not physical. The consequence is psychological. The consequence is perceptual. The consequence is behavioral. People react to narratives. They do not react to measurements. They react to framing. They react to imagery. They react to certainty. The expanding Earth narrative provides certainty. It provides a clear arc. It provides a target. It does not require uncertainty tolerance. It does not require data literacy. It does not require patience. The consequence is adoption. The narrative spreads. It attaches to new events. It recycles old observations. It persists because it fits cognitive shortcuts. Scientific communication must account for that reality. Dismissal does not work. Saying the narrative is wrong does not explain why it feels right. Trust the experts does not address underlying skepticism. Effective communication acknowledges the intuition. It validates the observation. It separates the geometry from the measurement. It walks through the constraints. It shows why the visual fit exists. It shows why the measurement overrides it. It does not condescend. It does not simplify. It demonstrates. It traces the path from observation to conclusion. It respects the curiosity that drives the question. It honors the data that answers it. The doublet does not threaten human populations. It threatens narrative integrity. It exposes the gap between remote measurement and public understanding. It reveals how quickly speculation fills observational voids. It shows how visual elegance outpaces physical constraint. The human consequence is not physical harm. It is informational distortion. It is trust erosion. It is misdirected attention. The remedy is transparency. It is access. It is clear communication. It is honest uncertainty. It is consistent demonstration. It is the quiet work of showing how the system actually operates, how the warnings actually function, how the measurements actually constrain, how the narratives actually diverge from reality. The consequence of ignoring that work is fragmentation. The consequence of doing it is alignment. The planet moves regardless. The question is whether understanding follows. Seismic events on plate boundaries do not occur in isolation. They occur within stress fields, within fault networks, within regional systems. The doublet on the Southeast Indian Ridge is one rupture. It is part of a broader pattern. It reflects accumulated strain. It reflects fault segmentation. It reflects the slow motion of the Australian and Antarctic plates. The consequences of that rupture extend beyond the immediate coordinates. They interact with adjacent fault patches. They influence regional stress distribution. They inform long-term seismic behavior. They connect to larger plate boundary dynamics. Stress transfer is the primary mechanism linking sequential ruptures. When a fault patch fails, it releases strain. It also redistributes stress. The redistribution has two components. Dynamic triggering operates through seismic waves. The waves travel fast. They impose brief, oscillatory stress on neighboring crust. If a neighboring fault is close to failure, the wave can push it over the threshold. Dynamic triggering occurs within seconds to minutes. Static triggering operates through permanent stress field changes. The rupture alters the surrounding crustal stress pattern. Favorably oriented faults see stress increase. Unfavorably oriented faults see stress decrease. The change is permanent. The response takes time. Static triggering operates over hours to years. The 11-minute gap between the doublet events sits between these regimes. It is too long for pure dynamic triggering. It is too short for typical static triggering. The gap suggests a fault system tightly loaded, two patches near failure. The first rupture provided the final push to the second. The stress transfer completed the sequence. Fault segmentation explains the equal magnitudes. Oceanic transform faults are not continuous planes. They are chains of smaller blocks, separated by stepovers, by bends, by geometric obstacles. Each block has similar surface area. Each block stores similar strain. Each block releases similar energy when it ruptures. That is why ridge transform earthquakes cluster in characteristic magnitudes. Magnitude 6 is common on this fault. Two blocks of similar size ruptured in close succession. The magnitudes matched, the geometry matched. The timing was unusual, the mechanism was standard. The doublet reflects segmentation. It reflects stress accumulation. It reflects the incremental nature of strain release. The broader plate boundary context amplifies the significance. The Southeast Indian Ridge connects to the Macquarie Triple Junction. The junction marks where the Australian, Antarctic, and Pacific plates meet. The boundary geometry becomes complex. Ridges intersect. Transform faults offset. Subduction components emerge. The Macquarie Ridge extends east and northeast. It carries transpressional stress. Compression adds to strike-slip motion. The result is larger earthquakes. In 1989, the Macquarie Ridge produced a magnitude 8.2 strike-slip event. The rupture extended over 220 kilometers. It reactivated a dormant fault section. The aftershock sequence was small. Oceanic strike-slip ruptures behave differently from continental ones. In 2004, the ridge produced a magnitude 8.1 event. It occurred 3 days before the Sumatra megathrust. The temporal proximity sparked research into remote triggering. No causal link was established. The events were independent. The coincidence was noted. The system was observed. The Australian plate moves north at approximately 7 centimeters per year. That motion is fast by tectonic standards. It drives rifting at the Southeast Indian Ridge. It drives collision at the northern margin. It drives subduction at the eastern margin. The plate is active. It is loaded. It is releasing strain continuously. The doublet is one release. It is part of the larger machine. The consequences of that machine are regional. They are systemic. They are predictable in pattern, unpredictable in timing. The plate boundary produces moderate events regularly. It produces large events occasionally. It produces quiet intervals frequently. The doublet fits the pattern. It does not break it. It does not signal escalation. It does not signal cascade. It signals normal operation. Cascading effects are often misinterpreted. Dynamic triggering is real. It has been documented. Large events trigger distant tremor. The 1992 Landers earthquake triggered activity hundreds of kilometers away. The 2004 Sumatra earthquake triggered remote tremor in Alaska. The effect is small. It acts on faults already close to failure. It produces minor earthquakes. It does not produce major ruptures. Global cascades of large events are not supported by data. Correlation does not equal causation. Temporal proximity does not equal mechanical linkage. Each major event has its own stress history, its own loading rate, its own failure threshold. The doublet is not connected to recent activity in the Aleutians, or Tonga, or the Nazca subduction zone. The events are independent. The catalogue registers them together. The system does not link them. The Gutenberg-Richter relation governs frequency-magnitude distribution. For every magnitude 6 event, approximately 10 magnitude 5 events occur. 100 magnitude 4 events occur. The relation holds across tectonic settings. It holds on oceanic transforms. It holds on subduction zones. It holds on continental faults. The doublet does not violate the relation. It is a statistical outlier in timing. It is not an outlier in magnitude. It is not an outlier in mechanism. It fits the distribution. It reflects the underlying stress field. It reflects the fault geometry. It reflects the loading rate. The consequences are measurable. They are predictable in aggregate. They are not predictable in sequence. Cascading interactions also involve stress shadowing. After a rupture, adjacent patches enter a relaxed state. They store strain more slowly. They fail less frequently. The doublet discharged local stress. The fault is quieter now. The next significant event will likely come from a different patch. It will likely take years to decades to occur. The cascade moves forward in space. It does not cluster indefinitely. It resets. It reloads. It releases. The pattern repeats. The consequence is regional stability. The consequence is localized risk. The consequence is long-term continuity. The system balances itself. It does not accumulate indefinitely. It does not fail globally. It fails incrementally. It releases incrementally. It moves incrementally. The human interpretation of cascading effects often diverges from the physical reality. The mind seeks connection. It links events. It builds sequences. It creates narratives. The physics does not require connection. It requires loading. It requires threshold crossing. It requires stress transfer. The doublet demonstrates that process. It shows how adjacent patches fail. It shows how timing compresses under high load. It shows how segmentation controls magnitude. It does not show planetary escalation. It does not show global linkage. It shows local mechanics. It shows regional stress. It shows standard behavior. The consequence is clarity. The consequence is understanding. The consequence is restraint. The system is complex. It is not chaotic. It is patterned. It is measurable. It is predictable in framework, unpredictable in detail. That is how plate boundaries operate. That is how the doublet fits. That is how the consequences unfold, incrementally, mechanically, consistently. Projecting future seismic behavior requires distinguishing observation from inference, from probability, from certainty, from measurement, from speculation. The doublet on the Southeast Indian Ridge provides a snapshot. It does not provide a forecast. It indicates past strain accumulation. It indicates recent release. It indicates fault segmentation. It indicates stress transfer. It does not indicate timing for the next event. It does not indicate magnitude for the next event. It does not indicate location for the next event. Projections must acknowledge that limit. They must work within it. They must not overstep it. Seismic forecasting operates probabilistically. It uses historical catalogues. It uses stress accumulation models. It uses fault geometry. It uses recurrence intervals. It produces likelihoods. It does not produce dates. The Southeast Indian Ridge has a recurrence interval for magnitude 6 events. It occurs every few months across the entire system. Locally, on a single transform segment, the interval is longer, decades, possibly centuries. The doublet discharged 2 adjacent patches. The probability of immediate recurrence on the same patches is low. The probability of activity on neighbouring patches is moderate. The probability of regional quiet is high. Projections reflect that distribution. They do not guarantee outcomes. They outline possibilities. They weight them by data. They communicate uncertainty. They do not erase it. Instrumentation gaps constrain projection accuracy. No ocean bottom seismometers sit near the doublet coordinates. No permanent geodetic stations monitor the ridge crust. No real-time strain sensors measure fault loading at depth. The global teleseismic network captures surface waves. It reconstructs location. It estimates magnitude. It approximates depth. It does not capture rupture propagation. It does not resolve exact fault dimensions. It does not detect small foreshocks. Those foreshocks may exist. They may have preceded the doublet. They may have been too small to detect from 1,000 kilometers away. The data gap is real. It is structural. It is geographic. It affects projection precision. It does not invalidate projection. It limits it. It requires honest communication. It requires uncertainty labeling. It requires restraint. Technology trajectories offer improvement paths. Distributed acoustic sensing uses fiber optic cables as seismic arrays. It increases spatial resolution. It captures microseismicity. It maps rupture detail. It requires cable deployment. It requires infrastructure. It is expanding. Satellite geodesy improves crustal deformation tracking. INSAR measures surface displacement. GPS networks expand coverage. Machine learning improves signal detection. It filters noise. It identifies precursors. It classifies mechanisms. It does not predict events. It improves monitoring. It reduces uncertainty. It increases resolution. The future projection landscape depends on instrumentation density. It depends on data access. It depends on computational capacity. It depends on funding. It depends on international cooperation. It does not depend on speculation. Long-term tectonic evolution provides broader context. The Australian plate continues moving north. The southeast Indian ridge continues spreading. The transform faults continue accumulating strain. The system will continue releasing it, moderately, regularly, occasionally larger. The probability of magnitude 7 events exists. The probability of magnitude 8 events exists on the Macquarie Ridge. The probability of megathrust events does not. The ridge is not a subduction zone. It does not produce vertical displacement. It does not generate megathrusts. It produces strike-slip ruptures. It produces transform earthquakes. It produces moderate magnitudes. The projection reflects that. It does not invent hazards. It does not amplify risk. It tracks mechanism. It tracks history. It tracks geometry. Timescale comparison shapes projection relevance. Geological processes operate over millions of years. Human infrastructure operates over decades. Human planning operates over years. Human attention operates over days. The mismatch creates friction. Projections must bridge that gap. They must communicate geological timescales in human terms. They must distinguish long-term probability from short-term risk. They must avoid false urgency. They must avoid false calm. They must maintain balance. The doublet does not change long-term projections. It updates short-term stress maps. It indicates local discharge. It indicates regional stability. It indicates continued motion. The projection remains consistent. The system remains active. The risk remains moderate. The timeline remains long. Uncertainty analysis is central to projection integrity. Confidence intervals exist. Error margins exist. Data gaps exist. Model limitations exist. Projections must state them. They must not hide them. They must not minimize them. They must integrate them. The doublet projection carries uncertainty in timing, in magnitude, in location, in stress transfer range, in fault geometry detail. The uncertainty is quantified where possible. It is acknowledged where not. It does not weaken authority. It strengthens it. It demonstrates honesty. It demonstrates rigor. It demonstrates scientific discipline. Projections without uncertainty are not projections. They are assertions. They are not scientific. They are speculative. The doublet projection remains scientific. It carries uncertainty. It respects data. It avoids overreach. It communicates clearly. It projects responsibly. Future monitoring will improve resolution. It will not eliminate uncertainty. It will reduce it. It will refine probability. It will tighten intervals. It will increase detection. It will map segmentation. It will track strain. It will improve forecasting. It will not enable prediction. That limit is physical. It is fundamental. It is accepted. The projection landscape will evolve. It will become more precise. It will become more detailed. It will remain probabilistic. It will remain uncertain. It will remain honest. That is how projection works. That is how it should work. That is how it will work. The doublet is a data point. It is a reference. It is a baseline. It informs future projection. It does not dictate it. It guides it. It constrains it. It improves it. The system continues. The monitoring improves. The projection refines. The uncertainty remains. The science advances. That is the trajectory. That is the reality. That is the path forward. The doublet on the southeast Indian Ridge is a quiet event. It occurred in deep water. It occurred far from land. It occurred without warning. It occurred without consequence. It registered in catalogues. It registered in research. It registered in public conversation through narrative attachment. It did not require escalation. It did not require panic. It did not require speculation. It required observation. It required measurement. It required context. It required restraint. The final reframe is not a reversal. It is a realignment. It returns the event to the system that produced it. It returns the narrative to the data that constrains it. It returns the question to the evidence that answers it. The Earth does not expand. It recycles. It creates crust at ridges. It consumes crust at trenches. It moves plates on a stable surface. It maintains a balanced budget. It rotates at a predictable rate. It preserves magnetic records consistent with fixed geometry. The visual fit on a smaller sphere is geometric closure. It is not planetary history. The expanding Earth hypothesis was a reasonable speculation when data was limited. It became obsolete when data arrived. The viral framing circulates the old intuition without the new measurement. It feels true because it uses real observations. It is wrong because it ignores the system that balances those observations. The reframe is simple. The planet is stable. The motion is real. The budget is balanced. The narrative is detached from measurement. The measurement stands. The doublet is plate tectonics working as expected. 2 fault patches accumulated strain. 2 fault patches released it. The timing was compressed. The magnitude was equal. The mechanism was strike slip. The location was remote. The hazard was minimal. The science is clear. The system is consistent. The event is routine within its class. It is unusual in its pattern. It is valuable in its clarity. It provides a clean example of stress transfer. It provides a reference for fault segmentation. It provides a case study for remote detection. It does not provide evidence for expansion. It does not provide evidence for cascade. It does not provide evidence for escalation. It provides evidence for standard operation. That is the reframe. That is the alignment. That is the reality. Human perception struggles with remote systems. It favors visibility. It favors impact. It favors narrative. Science operates on measurement. It operates on constraint. It operates on uncertainty. The gap between them is structural. It is not intentional. It is not malicious. It is cognitive. It is perceptual. It is behavioral. Closing the gap requires patience. It requires demonstration. It requires transparency. It requires honest communication. It requires respect for curiosity. It requires respect for data. It requires restraint from overreach. It requires commitment to clarity. The reframe is not a dismissal. It is an invitation. It invites observation. It invites measurement. It invites context. It invites understanding. It does not demand belief. It demands attention. It does not demand trust. It demands verification. It does not demand certainty. It demands honesty. The seafloor between Australia and Antarctica continues moving. The transform faults continue accumulating strain. The system continues releasing it. The catalogue continues recording it. The monitoring continues improving it. The understanding continues deepening it. The narrative will continue circulating. It will attach to new events. It will recycle old observations. It will persist because visual elegance travels faster than measurement, because simplicity spreads quicker than complexity, because intuition feels truer than constraint. The science does not compete with narrative. It operates beside it. It provides the baseline. It provides the check. It provides the correction. It does not erase curiosity, it guides it. It does not dismiss wonder, it grounds it. It does not remove mystery, it clarifies it. The doublet is one entry in a long catalogue. The catalogue is one record in a longer system. The system is one component in a larger planet. The planet is one object in a larger universe. The scale is vast. The processes are slow. The measurements are precise. The uncertainty is real. The reframe acknowledges all of it. It does not compress it. It does not simplify it. It presents it. It respects it. It holds it. The Earth is not expanding. It is moving. It is recycling. It is balancing. It is stable. The seafloor is doing what seafloors do. The faults are releasing what faults store. The plates are moving what plates move. The science is measuring what science measures. The narrative is circulating what narrative circulates. The gap will remain. The work will continue. The understanding will deepen. The planet will persist. That is the reframe. That is the reality. That is the record. That is the rhythm. It continues. It always has. It always will.